Hi, hello guys. Let's read this article of understanding database scaling patterns. So, some techniques in that database scaling. You see what this article have to tell about. So your small application grows larger and with the 10 bookings per minute increases to 20 to 30 bookings per minute and the system starts to perform slowly and some transactions deadlock or stop and they fail and the app is responding slowly causing customer dissatisfaction. So what can be done to solve these problems? So the pattern one is query optimization and connection pool implementation. So caching the frequently used non-dynamic data such as booking history, payment history in the application layer, but the problem of API exposing dynamic data like current arrival location or nearest track cache for a customer can't be cached easily. So when database is heavily normalized, some redundant columns are introduced which reduces the join queries and breaking big queries into smaller queries. So caching the database connection and stopping from a lot of communication between client and server prevents the costly network connection. Using the same database connection can improve the latency of APIs and reduce the latency, which is a good optimization. So after that, when your bookings increase 80 to 100 bookings per minute and the system cannot handle this scale, the pattern to vertical scaling or scaling up by adding extra hardware can be used. So upgrading the RAM by 2 times and upgrading the disks 3 times or more helps. So how can this machine be set up for vertical scaling? There will be a bigger machine, then manually transferring the data from old to new machine. The new machine added is as slave to existing master, and when the replication is done, the new machine is made the master, and the system is running up again with increased performance. So when still after the bookings increase a lot to 3 times from the earlier, the performance decreases and the memory and CPU use still increases. So another database pattern is Command Core Responsibility Separation (CQRS). The big machine or the new machine is not able to handle all read-write requests. Also, transactional capability is required on write operations, but not on read operations. And we are fine the delayed read operation. So you can separate read and write operations, the physical machine wise. So another 2 big machines are added as the slave to the current machine, and one machine will handle all the read queries and another machine will handle all the write queries, and the medium scale startups solving 200,000 requests can survive with his master slave setup such that they periodically archive older data. After you scale up your operations, now the master is not able to handle all write requests, and the write requests are having latency. So, for example, the customer pays to the driver. The driver cannot see the payment because the customer's activity is the write request that goes to master, and drivers is a read request that goes to the slave. Since master is slower, the driver is not able to see the payment for a longer time, frustrating both driver and customer. How can we solve that? Using the pattern for multi-master replication. So, distributing the write request to slave in the multi-master configuration, all the machines can work as master and slave in this type of configurations, so that B can replicate for the circle of machines A, B, C, D, and A. B can replicate data from A and C. D can replicate data from C and A. So data can be written to any node, and while reading the data can broadcast the query to all nodes, and whoever replies the return that all nodes will have same database schema, same set of table index TC, so that there will be no collision in ID across the nodes in the same table. So it's better to use UUID or GUID for ID. So read queries can be inefficient because it is broadcasted query and the correct result is easily scattered. So after scaling up again, pattern 5 partitioning can be used. So for example, the location database is getting high read and write traffic. So this is keeping the pressure on existing databases. So the location tables contains some primary data such as latitude, time, stamp, driver ID, people ID, but does not have much to do with user trips, user data, payment data, etc. So separating the location in separate database schema. So that the data can be partitioned by the functionality. Different database can host the data categorized by different functionality, and each functionality can be scaled according to demand of high read and write requests. Also, this requires more code changes, and after this, can use the pattern 6 horizontal scaling. So in this, there are 50 machines all have the same database schema, This contains the same set of tables, and all machines hold a part of the data, so the system can be designed such that all the related data lands in the same machine, and each machine can have their own replicas which can be used in case of failure recovery. Each of the databases is called shard, and a physical machine can have one or multiple shards. So a single sharding key refers to the same machine. A lot of machines holding related data in the same set of table, and the regard request lands on the same database machine. Also, sharding is hard, and when there are millions or billions of requests, there should be a tough decisions made. Having a sharding in place can be scaled to many countries, and the reason why is latency is again seen from different continents, and another pattern is using data center was partition. In this, our request has to travel across the continents, and there is latency because of different places. So what about distributing traffic across different centers so that data center in Singapore can handle requests from South Asia, Germany, data center can handle requests from European countries. So also data center replication can be done across different places, such as a Germany data center can be replicated to Singapore data center, and this technique is useful when you have millions of customers to serve across countries. I hope you learned something about database scaling and partition. Thank you guys. Bye.